Okay, so we are back in our woods with Professor Alfie, and he has presented us with a bit of a geometry puzzle to solve. So I'm going to hand over to him to explain what we're going to have to try and figure out.
Right, it's actually quite simple, or rather it looks simple.
Okay.
We have 4 trees, 1, 2, 3, and 4. And we try to connect these trees with a rope, and with this little rope we can achieve.
So you want to find the shortest way to connect all the points?
Yes.
All 4 trees.
But why, okay, devil's advocate again, why do I need to know this in my life?
Well, because you might encounter a problem, not with trees. Let's say you have various houses and want to connect them with pavements or streets or maybe electric cables, and look for a connection that costs as little money as possible.
Okay.
And this is equivalent to what we're doing now.
So if we were, for example, connecting our new feed sheds together,
Right.
there,
Yeah.
with the electrical cable that we need for...
Which is expensive.
Which is
right?
expensive.
Yeah.
Okay, well that I can understand.
You have to- Okay.
So, you're satisfied?
Well, we've got them all, certainly all connecting,
Yes.
but
Is it
what we don't know is if this is going to be the shortest route.
Well, do these 2 need to be connected? Because that one, you could go all the way around to get to that one.
Do you want to do it then?
So if you just
So we
bring
just
this
need
up
to,
this-
yeah, we could just stop here. So we've still got all 4 connected like that.
Oh, I see. So you've got a 3-sided oblong,
Yeah. And we can
Right.
get,
which is definitely less rope than if you connect all 4 together.
yeah,
And they still are all connected.
yeah. So it seems like it's taking up an awful lot of rope though.
Okay. Do you think
You
we
think-
could, do you think we could use this rope?
I bet we could. I bet we
Well,
could.
it but if you go to the corner,
All right.
you have like a roundabout in the middle.
Give it a go.
Okay. Do we need a way to remember where we got to on the rope, don't we? Okay. So that knot is option
1.
A, option 1.
Option 1, if we assume that the full rectangle is not an option.
Okay, so why don't you show them what you meant for your
All right.
first
Do you want
crossing?
to do what you thought?
So if you, Heinrich, you go to that tree, and Rupert, you go to that tree, and just cross in the middle. And you have. Why is that more?
So we
No.
need more. That's longer.
no?
Sure, we have.
You know why? Because we don't need that bit in the middle.
We don't need that bit in the middle.
Which
So we
bit?
might-
That bit. We don't
Yeah,
need that
because
bit.
they're all connected without that.
From Josh.
So if I-
No, we have no connection between these and these.
You'd
we
go,
cut this.
oh, you're right, you're right. You are right.
Okay, so this is actually longer
Yeah.
than the one we just tried.
Even
Yeah.
without that bit?
Yeah,
Well, we
We need that bit because otherwise you can't get.
you have no.
No,
Yeah,
No, you don't need it.
Right.
you don't need it.
Just drive down this bit to go
Oh,
that
yes,
way, and then
you're
drive back that
right.
way.
If this is a crossing, where you might cross over from one to the other, you don't need it.
So we need to
So if we get
This, of course, is longer than before, because you replace the direct connection with the diagonal, and again, the straight direction with the diagonal. That couldn't work.
We just need to somehow cut that out.
So our intelligent team has a new idea.
Yep, so in order to figure out the length of this, we're going to measure this and minus it from Josh because we don't
From the
need
knot,
this
yeah.
part. Okay.
that's x minus Josh, is that the equation?
Yeah, that's the equation. So, Henrik, can you hold
minus,
that?
minus Josh's. Josh.
Okay. That's
Minus.
that about right? Yeah, okay. All right, so I need to go minus from Josh
Minus me,
without.
without falling over.
Okay, that's quite a bit
We're probably a bit short.
quite a bit shorter. So
So
we need another.
another node or a new node here.
Yeah.
You want to make a knot?
No, you probably. I'm a theorist.
And that's a different, not a sailor.
Right.
All right, so that's definitely shorter.
Okay, so that one.
So you might dissolve this knot now.
So why isn't that the perfect one then?
Just try something else and you'll find out.
Okay.
It's not the perfect one, and well, I suggest you give it a little thought to find what could be varied.
What about like?
Try a heat.
So like those two and then something across the middle.
Yeah.
Oh, let's try that.
So then we only have
I'll do
one.
one line.
Okay. So you two need this.
So you guys swap again, right?
To get straight.
Yeah, so we get an H.
Okay.
Do the little dance, and then you go to that tree.
I like to do the dance.
But why would we need?
But then we don't need that. We need to officially move that
But
down.
that's the same distance.
So then that's the same
It's
distance.
the same, isn't it? Yeah. So that we're just gonna move that down.
So it would be the exact same as that. It's that far.
So, but we could switch the 8 around, right? So we connect the two short sides, and then we have one long one in the middle.
All right.
That might make it shorter. So we try it.
Two
Alright.
short sides.
So you take this one.
I take this one.
You take this one.
Okay.
And then that would be in the middle?
Yeah, but we don't need to move it to
Yeah,
the middle. It's
yeah.
doing the same thing.
So
So-
okay, so this and this plus that down the middle.
Oh,
Yeah.
that's
Yeah.
way shorter.
Okay.
That's shorter again. Look.
Look where your knot is.
Okay. So do I want to make a little
Make
Yeah.
a little knotty thing.
and not such a water thing?
Okay.
Alright.
So what about that?
This is sort of a substitute for what you actually want, right?
Okay. So we were along.
So
Something just occurred to me. Where Alfie was just saying that we were getting warm was somewhere between the cross and the H.
Yeah.
So what's a hybrid? What would a hybrid between the cross and the H look like?
A bendy H.
A bendy.
sounds like a good idea.
Okay, so if you just stay there, keep holding that. Just because I just want to map out something. Okay, look, so we had, where you said we were getting the warmest was when we either did a cross or when we were thinking with one line there, one line there, one line connected. So what I want to do now is try and create a hybrid of the two. So what's the closest you and me can get to the cross? If we pull it as taut as we can, if you come into me as much as you can, Heinrich, and I'll come to you as much as I think I'm about where I can be. Can you come any closer? And can we pull it really taut? Like pull that one taut and pull this one taut. Are we on the right track?
Looks good, yes.
Give me the red one.
The red one, okay. Now you had a question though.
I feel like the straightest line between the shortest distance between two points is one line. So I don't understand why this V makes it shorter.
I think because we've made this so much shorter.
I may give you an example by making a sketch in the sand. Is that okay?
Yeah.
Please.
Let's take an extreme example, a rectangle that's very, very long. And
Long enough.
so here's one tree, here's one tree, and then there's a lot of distance from here to here. Now we could have a cross from here to here, but then the problem is both lines have to cover nearly the whole distance between these two pairs. So if you go out here and say, well, that doesn't make sense just to have those meet here and then go over in one line, and then at an appropriate point it splits again. It's obviously shorter because you don't have to cover that long distance with 2 lines.
So what I'm observing, just purely, you've got a fairly oblique angle there, right? And if the more taut I can make this, the more oblique I can make this, the closer it's going to get to you. So what I'm wondering is, should we go on up to the riding arena and do this in a place where we can control the distances a bit more? Maybe use the jumping standards and see if we can do this thing, because it seems to me that it's 2 oblique angles connected. That's going to be the give us the
how about
solution here.